Flip lesson 97. We are in for a whirlwind of fun today as we work with what's known as transversals. Transversals really have a simple definition. It says a line that intersects two or more lines. So looking at this diagram in front of us, these lines in front of us, we see line Q, we see line R, and we see line G. And we want to find the transversal in this case. And in this case, we're going to have a transversal that crosses two lines. And so we can easily circle that line G would be considered a transversal because it intersects two or more lines. And so we see something pretty simple like that. However, while that gives us our definition of a transversal, we specifically want to look at, transversals that are going to intersect two parallel lines. Because when you have a transversal that intersects two parallel lines, you get some unique properties that come out of that transversal. So in this case, we have line W is intersecting F and Z, and in this case, F and Z are parallel. And so we can start to see some relationships. All right, let's start by looking at our first idea and reviewing the concept of supplementary angles. Supplementary angles, remember, are angles that are side by side, and when you add them together, the measure of their angles equals 180 degrees, also known as a straight line. So when they're side by side, they're going to make a straight line together. All right. So let's name some supplementary angles. All right. We want to form straight lines. Okay. So I see a straight line right here, and so I could say angle 1 is supplementary to angle 2. So I could say angle 1 and angle 2 are supplementary, and that would be very true. I could also say, well, I also see a line going like this. So I could say angle 5 is supplementary to angle 5 is supplementary to angle 7. All right? And so we have that idea. All right, take just a minute, pause the video, and name two more supplementary angles from this figure. All right. You named those two supplementary angles. Now we're moving on to what are known as corresponding angles. Corresponding angles are angles that are in the relative same position. Because we're dealing with parallel lines, as this line, line W, goes to intersect both of them, there's really a pattern that you see. And that's where we get corresponding angles, angles that are in the relatively same position. So if I look at angle 1 here, as I look at angle 1, I see that it's in the top left corner, and as it intersects, it's going to have this acute angle. Now as I continue my way down the line, you can see that angle 5 also has that exact same angle, that exact same shape, and is in the relatively same position. And so I could say that angle 1 and angle 5 are corresponding angles. And so we have that idea, that they are corresponding angles. Go ahead and use this picture and name two more corresponding angles based upon what you just learned from this example. All right. After you finish that, make your way to part 2 to learn about the last two major concepts in this lesson. Welcome back. As you look at alternate interior angles, we need to first talk a little bit about location found within transversals that deal with parallel lines. Okay, so we have three distinct regions. All right, we have a region that kind of covers from here up. Right, we have a region that focuses on here, and then of course we have a final region that looks at back here. And what we see here is we have what's known as the exterior. Okay. We have the interior, right, the inside. And once again, we have an exterior. And you can see that relationship. You see the top part is on the outside, the middle part, the interior, right? 3, 4, 5, 6, those are the inside, and 7 and 8 would be exterior. And so because of that, you have what are known as exterior angles, 1, 2, 7, 8, and interior angles, 3, 4, 5, 6. And what's really neat, because of the fact that you have a transversal going through parallel lines, is you start to have relationships that exist between these ideas. All right? So, it says alternate interior angles. They're going to alternate, right? Alternate means opposite side, and have the same measure. All right? We could talk about the measure of an angle, or in other words, how many degrees an angle is measured in. So measure of an angle. Alternate interior angles. So they're interior angles that are on the opposite side and have the same measure. All right, look at the diagram here and see if you can use this definition, to help you understand two alternate interior angles. Did you figure it out? All right, let's look at it. I kind of gave you some big hints because I've color-coded them a little bit. But we can see this, right? If I'm looking at the inside, I'm going to start with angle 3. Angle 3, we see it's an obtuse angle, just like this. And now I want to compare it, right? I'm going to go opposite side, okay? Opposite side, so I'm not staying up here on this side. I'm going to this side, right? And it has to have the same measure, right? So it's going to have to be that obtuse angle. And so right here, I'm going to say that angle 3 and angle 6 are alternate exterior angles. So one set is 3 and 6. 3, I should say, and 6. All right. Now that you figured that, go ahead and name the other pair. Now that you understand alternate interior angles, of course, we also can have alternate exterior angles. Exterior angles that are let me start over. Exterior angles that are on the opposite side and have the same measure, right? So here I'm going to start with number 1, right? That's my acute angle on the outside. I'm going to look to the opposite side, right? Here's the opposite side, the opposite exterior. All right, found my acute angle. That's number 8. Same measure, opposite side, right? Opposite side. And just like that, I've determined my first set of alternate exterior angles. So what would be the second set of alternate exterior angles? Go ahead and do it. All these definitions leave a lot to understand. We see relationships. And what you're going to do in your sample is now you're going to start applying these definitions by looking more at numbers, right? When I start to give you the measures of angles. As I give you the measures of the angles, can you figure out the measures of the rest of the angles? And then finally, you do the second part right here, which is going to look at, well, what big truth or what rule could you write about acute angles and obtuse angles found within transversals? So take it a step at a time and work through this. That's lesson 97.